Welcome to the OutSystems Asynchronous Logic webinar. Asynchronous, process in a multitasking system whose execution can proceed independently in the background. Other processes may be started before the asynchronous process has finished, opposed to synchronous. Asynchronous logic in the OutSystems platform is achieved through the timer element. Timers are OutSystems background processes, also known as batch jobs. Timers allow scheduled task processing and are run outside web application context, meaning that there's no web screen flow logic, no authentication context or logic, and no session context. Over the next 8 minutes, you'll be walked through all the features made available by the OutSystems platform to handle asynchronous tasks. Over a real-life scenario, you will be shown how to define asynchronous tasks and how they can be scheduled and monitored. Then, you'll see how to handle long processing tasks. Finally, we'll show you how to speed up user interaction and save up some precious resources. Let's take a look at a real-life scenario. Meet Jane. Jane is an OutSystems consultant who has implemented an OutSystems software factory at Successful Business Incorporated. In this factory, there are several applications that automatically send emails to customers and suppliers. In its daily activity, every time a user triggers an action that sends an email, the user is kept waiting until the email is sent. He has to wait, since the click of a button on the web screen, until the email sending process is actually finished. Furthermore, it's not uncommon to have several users triggering these actions simultaneously, meaning that for each email sending action, there is an email sending process running on the server, which obviously brings some serious performance and resource issues. Facing this problem, the customer asks Jane how this can be solved. Being an experienced consultant, Jane knows exactly how to solve this problem. It can be solved using asynchronous logic. Sending emails asynchronously will no longer require users to wait for its conclusion. Also, Jane will make sure that only one email is sent at a time, avoiding simultaneous email sending processes. This will be done by creating a new e-space on which an email queue will be defined. Then, Jane will create a timer that periodically sends the enqueued mails. Finally, all e-space references to the reach mail send action will be replaced by an add email to queue action. Let's implement this. We'll start by defining an email sending timer. As planned, Jane created a new e-space called Email Services. On this e-space, Jane exposed an add email to queue action, which enqueues emails in the email queue entity. Then, Jane defined the send enqueued mails action that queries email queue entity and sends all enqueued emails. Now, we just need to define a timer that will asynchronously execute the send enqueued emails action. To define a timer, you must right-click on the timer folder in the right pane tree view and select the Add Timer option. Then, you must specify the action that will be executed and define its execution schedule. You can also specify the timer's priority of execution, taken on consideration when the number of simultaneous running tasks reaches the maximum defined, 3 by default. Furthermore, you can specify the timer's execution timeout. Having our timer defined, we'll publish our e-space and see how the timer can be managed and monitored through Service Center. In the e-space edit screen, we'll click on the Timer tab and see the timer we've just created. By selecting the timer, several options are made available. We are also presented with useful information about the timer's schedule and execution. Let's access the timer's detail, which can be done by clicking on its link. As you can see, several timer management and scheduling options are made available. It is possible to specify the timer's execution schedule overriding its default definitions. The same applies to the timer's priority of execution and its execution timeout. Along with timer management, Service Center allows you to monitor timer execution. This can be done by accessing the timer log. Here, all timer execution history is presented. We can see which timer ran when and for how long. We can also monitor errors that might have occurred. Jane's eSpace was published on the customer's environment, and as expected, things worked out just fine. Users were no longer being kept waiting. Email sending tasks would be enqueued and executed according to the timer schedule definition. As you can imagine, the users got more productive, and soon email sending actions were being triggered at a much higher rate. When everything seemed to be working perfectly, Jane noticed the problem. She checked out the timer log in Service Center and realized that it was returning a timeout error. Fortunately for us, Jane also knows how to work around this problem. If only a few emails are processed at a time, the timer's execution will no longer expire. Let's implement this. We'll start by lowering the amount of records that are fetched from the email queue. Then, we'll add some logic to check if there's any email left to process upon current timer execution. If so, we will explicitly wake our send-enqueued emails timer. This will cause our timer to rerun as soon as possible. Jane has finally got it right. Emails are only sent a few at a time, assuring the timer's timeout limit is never reached. Each time the timer finishes its execution, if there are any emails left to process, the timer explicitly awakes himself until there are no more emails on the queue. Jane got so pleased with this solution that later on, and upon improvements, published it as an OutSystems community solution. Today we learned how to create a timer for periodic processing. Then, we've seen how to schedule, manage, and monitor timers. Afterwards, we've seen how to handle long processing tasks. Then, we've learned how to wake a timer for background processing. Finally, we've seen how to speed up user interaction and save some precious resources.